The demo today is based on a fictitious e-commerce company called Global Shop. And let me quickly talk through the architecture of this. So imagine that there is a high volume e-commerce website that exists. It operates globally. It has a presence in different countries, different markets, and there is a continuous stream of clickstream events that is generated as users navigate through the application. And then also there's a continuous feed of transactions that may be fraudulent. So this is an example of the architecture here in the demo. And so this is using multiple of the connectors that Ankit just talked about. So it's using the new Kafka connector in Openflow, which is now GA. It's using the Kinesis connector, which is in public preview. It's using the Snowflake to Kafka connector as well. And I will be demoing from Openflow BYOC, which is going to be deployed in AWS. And then, so obviously, Openflow is going to cover getting the data into Snowflake and also getting data out of Snowflake back into Kafka. After the data is ingested, there's going to be processing happening within Snowflake. In this demo, I'm primarily going to be using dynamic tables. One thing that's also in the demo that is not listed here on the slide is that I will be using low latency dynamic tables, which is also in private preview. So that enables dynamic tables to process at a lag down to 15 seconds, which is something that previously wasn't possible. I'm also going to be using triggered tasks. So when you log into Snowsite, you'll notice in the last week or so, there's a new tab that's appeared under data called Openflow. And this is where you can get to the launching point to open up the Openflow control plane. So I'm going to click on this here, and you can see there you can list your different data planes. In this case, I just have one data plane, but there's nothing to prevent you from having more than one. You could have them in the future in different cloud platforms. You could have them running in AWS and also Snowpark Container Services. There's going to be lots of options here. But that is the actual underlying infrastructure that actually hosts the Openflow clusters. Openflow itself, the actual engine, runs in something called a runtime. And so you can see here, I have 4 different runtimes running in my account. 2 of them are active, and then 2 of them are suspended. And so these are very easy to create. I could easily spin up a new one. I could choose a size. I could configure min and max nodes to achieve auto scaling, all with just a couple clicks. Now, I'm going to quickly show one other thing here before I get into the main part of the demo, which is if you go back to the overview tab, you can see different connectors. And so these are all of the pre-built connectors that have been released here at Summit. And you can see things like Kinesis and Kafka, lots of different connectors for unstructured data, CDC connectors. You know, they're all here, and they're all pretty easy to install. All you have to do is just click on Add to Runtime. Choose a particular runtime. The runtime has to be turned on. So I'm going to install this Kafka connector right here just to show you kind of what the process looks like. Just give me 1 second to log in. All right. So this just takes a couple seconds. And the core idea here is I just installed a connector onto infrastructure that I didn't have to provision. I didn't really have to do anything other than install the data plane initially and configure the runtime. So once you install a connector, the main thing that you have to do is just configure all the different connection information, like where's what are the brokers in this case of your Kafka cluster? Where do you want to ingest the data into? What Snowflake account? What the database schema table? Things like that. And these settings have all been modeled after the existing Kafka connector. So if you're using that today, there's a pretty easy migration strategy to get to Openflow. Now, I'm not going to go through now the process of trying to configure this. What I'm going to do instead is I'm going to jump back and go to a different runtime, which is already configured, already up and running. This is the actual demo use case that I just talked about. The runtime's called Global Shop. And so this is an example here of the main canvas for Snowflake Openflow. And so you can see that there's basically 4 boxes. These are called the process groups. And these are ingesting from Kinesis, Kafka, and then I have 2 connectors here that are reading from Snowflake and then writing to Kafka. This is data coming from Amazon Kinesis. And so I can go into the process group, and you can see here, this is pretty much the exact connector that you would get if you installed the Kinesis connector, with the exception of this box here to the left, which are various in-flight transformations that I've added for the sake of this demo. So let me quickly talk about what this is doing. So you'll notice here, there's a source processor called consume Kinesis stream. And this is configured to consume from Kinesis. And some of the stuff that you can do here in Openflow is you can view status history, and you can get all sorts of different metrics is to the performance of the connector. And so you can see here, I had turned this on maybe about an hour ago. There was an initial spike where it read data off the stream. It was kind of a backlog, and then the platform actually scaled back down and then kind of stabilized. So these are just raw clickstream events that are coming from Kinesis. If you want to see what the data looks like, one of the things that you can do as well is you can turn off a processor, and then you can go to list queue here, and I can get a sense of the actual incoming data. So I'm going to see that there are JSON records. These are the clickstream events. Give me 1 second here. So yeah, this is what's coming in. In this case, this is a clickstream event for a user in Japan, hence the Japanese. If I scroll down a little bit, I might see some users from, here's someone from Brazil that did an add to cart event. What I ultimately want to do with this data is I want to calculate a real-time user engagement score with it. But it's a lot of data. It's a big stream of all these different events that need to be aggregated and tied together to create kind of a composite score for the user in engagement. Now, let me turn this one back on here. So get that processing again. And let's quickly talk about the custom transformations here that I've added. So one of the challenges that we faced at Global Shop is we have bot traffic. And so that would be something that we don't want to waste the resources to calculate engagement scores for bots, obviously. And then the other thing that's happening is there's some late arriving data. So that's also the kind of thing, if you think about a system that's processing in real time, that could impact the calculations. It could make it more expensive if you have to calculate a session score on data that's old. And ultimately that wouldn't serve any business purpose. So the first thing that I'm doing here is I'm using something called the scripted transform record processor. And I have a small script that I've defined. This could be done in a bunch of different ways, but it's pretty easy to make these small little scripts. And so this is just some pretty basic logic here, but this is looking at the user agent of the events coming off the clickstream, looking at the timestamp, and then applying some rules. Is this a bot, and is this data late? From there, let me go over here a little bit. You'll notice that there is a filter processor here. So this is basically going to drop all of the bot traffic. And then moving over a little bit more. Partition late data. So this is taking the stream of all the clickstream, and based on the enriched field that I added, is the data late or not? It's actually splitting it into two separate partition streams. From there, I can route it differently. And so what we've decided that we want to do is we actually want to ingest the late arriving data, but we want to have it go into a different table. So after the partition processor, there's a route on attribute processor that sends the late data here and sends the on time data forward for additional processing. And then there's one more thing that I've added here, which is that I wanted to, and this is more of a performance optimization, but I wanted to pre-calculate a window ID. And so this is adding an additional field, which is basically using the timestamp to derive a window ID that's going to be used to optimize the transformation process once the data gets into Snowflake. So let me quickly kind of see the output of this, so you can get a sense for what this is doing. So just give it a second. You'll see that there's now some data that's gone through those custom transformations. I can go to list queue again, and I'll notice that there are some different flow files here. That's the main unit of how data moves through Openflow. And you'll see they have different sizes. Some of them are about 600 kilobytes. Some of them are more like 5 to 15 kilobytes. These are the ones with the late arriving data. So this is what I was talking about how the stream has been partitioned. And so if I click on view details, I can see that these are going to a different table. You click stream events late. That was the purpose of that overriding table name that I had added. If I go to a different one of the larger flow files, I'll see that it's going to the main table. So that's the idea. Like I've applied these different transformations, and the data is going into, ultimately, it's going into a processor called put Pseudopipe Streaming. And so you'll notice this across all the connectors. This is basically how every single connector in Openflow, every pipeline, if you want to stream data into Snowflake, this is what you're going to use. And prior to that, there's a process group here called evolve schema, and there's one called create table if it not exists. So these are things that you don't have to worry about creating your streaming tables. This can automatically perform schema evolution and easily get data into Snowflake. So that's kind of the core idea of this one that's ingesting data from Kinesis. If I want to see what it's been doing, the other thing I can do is I can see that I have 2 nodes here running. They've both been sending approximately the same amount of data, and I can scroll down and I can see records sent to my main table, and then records sent to my quarantine table. So let's see, records sent to the main table. These are 5-minute averages. It sent about almost 10 million records in the last 5 minutes. And then late arriving data is much smaller, about 100,000 records per 5 minutes. So that's the idea. So now if I back out, I see I've been sending all this data into Snowflake. What's coming out? So this is the Snowflake to Kafka connector that we just talked about. So here, if I go in here, I'll notice that there is a consume Snowflake stream processor. This is what's actually connecting to a stream within Snowflake. In this case, it happens to be a stream on a dynamic table. So there was one transformation that I wanted to do. In this case, the dynamic tables have full streams rather than append-only streams. I wanted to remove the CDC records that show that a particular session score event has been deleted. I only care about new scores in this case. So I've just added this one additional transformation here. Let me actually, before I talk about what's happening in Snowflake, let me just pause this one and quickly look at one of these events that came out of Snowflake in this particular connector. So this is the result of the processing here. And so what I'll see here is that the data is also in a JSON format. And I see a particular session from a particular country, a particular device type. These are the different events that they had. This seems like a longer session. They have a very high engagement score. I can see when the last record that was used to process this particular score, and then I can see when I queried it from Snowflake. So this is all the data that I could use if this record went back into Kafka. I could have a process, as Ankit mentioned, that's automatically updating my recommendation engine, my retail website, whatever, to use this information. In this case, I know this is a very active user who's been very busy on the site. They have a very high engagement score. So that is the idea there. And so this has been running continuously now for about the last hour. And as you can see, the amount of data going in, you could see this kind of like read-write is much bigger than the amount of data coming out. So let me quickly talk about now what's happening within Snowflake. So if I go to, let me go to this dynamic tables link. This shows the actual pipeline that I've used to perform this calculation. I basically have a chain of aggregations. So it's taking the data, it's performing a 1-minute aggregation, then a 5-minute aggregation, then an hourly, then a daily. And this is what I had mentioned at the beginning, that this is something that's very new. This is in private preview. These dynamic tables have a target lag of 15 seconds and a current lag of 6 seconds. So that means that I'm able to process the entire click stream in this particular refresh cycle within 6 seconds, which is something that has not been possible up until now. And then let me just take a look at this particular dynamic table here quickly. So this is my first chain of the aggregation. This is a 1-minute aggregation. And we can see here that this is taking about 3 to 5 seconds to refresh. Current lag is about 12 seconds. I've been able to stay within my 15-second target about 85% of the time. And this is processing about 48,000 sessions that are changing every 15 seconds. So that kind of gives you a sense of like the kind of things that you can do on the transformation side within Snowflake after you use something like Openflow to stream data in. And then let me quickly here just talk about the other part of the demo, which is, let me go back to my canvas. So this is for the transaction processing. These are transactions that are coming from Kafka rather than Kinesis. As you could imagine, there's not as many transactions as there are clickstream events. This is what the Kafka connector looks like. And in this case, I haven't done a ton of transformations here. Again, I'm using the convention of this box just to show the one change that I made, which is I'm actually masking the credit card number for PCI compliance, things like that. And I'm creating a SHA hash code, so I can identify what the credit card number is without actually knowing all the digits. So that's the one transformation that I've added here. You can get a sense of kind of what that looks like. It's not that much code. I've been using Groovy for the examples that are here in the demo, but you can also use Python as well. And if you're not familiar with Groovy, it's very similar to Java. So if you have Java code, you can pretty easily convert it to Groovy. So that's the idea there. And so I have these transactions that are coming into Snowflake continuously. And then on the Snowflake side, how am I actually processing them? So let me go to my task history here. I'll see that I have a task called Global Shop Fraud Transaction Scoring Task. And so this is a triggered task configured to run every 10 seconds. And you'll notice that my executions here are probably taking about 2-3 seconds each. So pretty much I'm calculating these, scoring the transactions, running them through an inference model every 10 seconds. So after that's done, what comes out? Let me jump back here to Openflow. This is these fraud alerts that are going back to Kafka. So let me jump in here, and we'll get a sense of what this looks like. You'll see that there is the data coming out. So this is the data that's already been processed, and this is again. This is pretty helpful to be able to, pause parts of the connector and to see what's happening as it's running. In this case, I can see there's a Japanese transaction where they paid with PayPal that has a very high fraud score for some reason. So that's the idea there. So I guess if I back up for a second, this is what it's like to use Snowflake Openflow. You can easily install these connectors. You can make minor changes to them. Or if you want to, you can build your own pipelines from scratch. I mean, that's an option as well. And these connector templates have a lot of helpful pieces in them. So if you did want to build a custom pipeline, it's pretty easy to grab stuff like this evolve schema or create table processors and then easily add them to a custom pipeline and, pretty much load data from anywhere to anywhere using this platform. And so I think that's it for the core demo here. Let me jump back to the slides for a second. So the future of streaming is Snowflake. There's a little bit more to announce. It's not just this particular demo. I'm excited to also introduce Snowpipe Streaming version 2. So this is a major change. Everything that I just showed you in the demo is based on Snowpipe Streaming version 1. Version 2 is a fundamental redesign that it targets the much higher throughput, up to 10 gigs per second per table. It's designed to ingest data in a format that's optimized for query performance. So you can take really, really high volumes of data and have end-to-end latency of 5 seconds from ingesting them to being able to query them. And then the last big change is there's a totally different pricing model. It's throughput-based pricing. It's going to be much more predictable. Snowpipe Streaming sometimes was kind of hard to predict what it was going to cost. This is going to be very, very predictable, much less guesswork. And so you'll know exactly what it's going to take to ingest data into Snowflake. And that's it. Thank you.